Okay, so we're going to look at a problem of two interacting objects, solving forces of two interacting objects. And the problem reads, in the figure presented, a constant force applied of magnitude 20 newtons is applied to block A, which pushes against block B. The block slides over a frictionless surface along the x-axis. What is the horizontal force of block A on block B? All right, so it's pretty straightforward two-object problem. Now, we are interested in a force, so we're going to do a force analysis, and we're interested in the force of block A on block B. So block B is our object of interest. All right, so let's look at the forces on block B. Well, we're going to do both the force free body diagram, which is part of our first analysis, and then the interactions to keep that practice and habit up. Well, we know we have the force of gravity acting on block B. Okay, and the force of gravity on B is between B and the Earth. We know there's a normal force on block B, and that is between B and the surface. And then we also know that block A is touching block B, and block A is touching block B such that the force is in the rightward direction. So this is the force by A, and that's on block B and block A. So there's no friction involved, so we are going to ignore any other forces. That's it. Those are the only forces, only interactions I can see for block B. So let's continue our force analysis. We have horizontal and vertical. Our acceleration is going to be along the x-axis, so it's our normal coordinate system. So I don't need to rotate my coordinate system in this problem. All right, so let's number our forces. So force number 1, nothing horizontal, just the force of gravity acting down. Force number 2, that's positive, and it's the force by A, nothing vertical. And force number 3, nothing horizontal, only vertical forces. So applying Newton's second law, we know that the sum of the forces is equal to the mass times acceleration horizontally, and the sum of our vertical forces is equal to the mass times acceleration vertically. And just because we are just in the horizontal plane moving, we still want to make sure we're asking these questions. So which direction is the acceleration happening? Well, it's along that horizontal axis. There's no change in motion in the vertical axis, so we know those forces are going to sum to 0. We're interested in the force on A. This is the one we want, so let's go after it. Sum this side. Forces on A is the mass of object B times the acceleration of object B in the horizontal direction. And I know that the mass of object B is 6, but I don't know the acceleration of object B, so I need the acceleration of B. Well, I'm not going to get it in the vertical direction because there is no horizontal acceleration in the vertical direction. So I want to start asking, what else is that acceleration related to? Well, block A and block B are moving together. So if I look for a relationship for block B, the acceleration of B, I can see that the acceleration of B is equal to the acceleration of A. And the acceleration of A is caused by the forces on A. So let's do a force analysis of A. See if we can't get that acceleration of A. All right, so if we do a free body diagram on block A, I have the force of gravity of A, which is the mass of A times G. And I have a normal force, so it's sitting on a surface, so that's the normal force on block A. And there's this force applied to block A. It's pushing it in this direction, which we know to be 20 newtons. It's given, that force applied. And then block B is interacting with block A, and it's sort of interacting in the opposite direction. So That's the force by B. So again, just to be attentive to what those interactions are, we know the force of gravity on A is between A and the Earth. And our 20 Newton force, our force applied, is equal between A and the actual thing applying it. We don't know what that is, but we know there's something there because we're told there's a force there, so there has to be an interaction. The normal force on A is between A and the surface. And the force by B is between A and B. So, like we always do, we're going to break these up into horizontal and vertical components. So 1, 2, 3, and 4. And our horizontal forces, so number 1, nothing. That's just minus the mass of A times G. Force number 2, well, that's a positive 20 newtons, but nothing vertically. We're given that value. Force 3, we don't have anything horizontal. That's just the normal force on A, and it's positive. Force 4, well, that's minus the force that B is exerting because it's to the left, and nothing vertically. So we sum the forces horizontally to give us the mass times the acceleration horizontally, sum the forces vertically to give the mass times the acceleration vertically. Again, asking our question, what direction is this object accelerating? Well, it's accelerating in the same direction as B, so we know that's horizontal, and nothing is changing vertically. All right, so we have 20 minus the force of B is equal to the mass times the acceleration of A. And we are going after the acceleration of A. So I know the mass of A is 4. And now what about that force of B? Well, A and B are interacting with each other. So the magnitude of those forces are going to be equal. That's Newton's third law. The size of the force is the same. And then directions are opposite. Well, this one was positive and this one was negative. So this force of B is minus force A. So all of these values can turn into force A. Well, then I'm left with 20 minus 4 times the acceleration of A, this should say A, not V, there we go, is equal to the force of A. And I also know that the force of A is equal to 6 times the acceleration of B. And I know that the acceleration of B is equal to the acceleration of A, so this is really 20 times 4 times the acceleration of B is equal to the force by A. So I can relate these two equations. 6AB is equal to 20 minus 4AB. And I can solve for my acceleration of B. Bring this to the other side. I have 10 times the acceleration of B is equal to 20. So the acceleration of B is equal to 2 meters per second squared. And I was interested in this force by A. Well, the force by A is equal to 6 times 2 or 12 newtons. So when we're dealing with forces of interacting objects, we need to recognize relationships, similar to when we were dealing with motion of two objects. Recognizing those relationships. How are accelerations related? How are the forces related? And then we can use that information to conceptualize the problem and ultimately solve it. All right, good job.